Hey guys, and so let's look at question 4. So it says ABC and PQR are arcs of a circle subtending angles measuring 30 degrees and 45 degrees respectively. So let me just kind of color code that. ABC is 30 degrees, PQR 45 degrees. And at the center of the circle. Part A says, can you find the ratio of the length of the two arcs? Once again, I'm just going to draw because it's quite hard to visualize and solve it. So I'm just going to say, okay, 30 degrees. So let me just create something that's like just roughly 30 degrees. And so it actually forms a circle. And so let me just complete that. And so this is actually ABC, but ABC is the arc. So ABC really is this part. This is ABC. And then we have PQR. It's of the same circle. It's of a circle, right? So it's arcs of one circle. So let me just draw it, but I'll just draw it separately so it's easier to see. If I have 45 degrees, so it's just a sketch, roughly 45 degrees. And this radius, I realized that this radius and this radius is the same because it's the same circle. And now the arc formed by the 45 degrees is this length, which is PQR. So let me just label that. This is PQR. This. And so the question says find the ratio of the lengths of the two arcs. So it's asking me the length of this arc divided by the length of this arc, basically, right? Of course, this is just a very diagrammatic way of showing it. And so how do I find the lengths then? So we go back to the formula. The formula that I know is that arc length. Once again, S equals to R theta, and theta must be in radians. And so let's do that. So for ABC, we can say that the arc length is R theta, but theta is 30 degrees. And how do I change 30 degrees to radians? Let's do it separately here, quickly. Degrees to radians. So once again, in previous videos, I put 180 to pi. I'm going to show you a slightly different one. If you don't like that, you can say 360 degrees is always 2 pi radians. So some people might be more familiar with this. And so now I want 30 degrees. I want to convert it to how many radians. So let me just do that first. I'll divide by 360 on both sides. And then from here to here, I would say I will multiply 30 on both sides. So I'm just going to do it this way. There you go. So this 30 degrees converts to that radian. So I'm going to do it over here. So that's 2 pi. R multiplied by 2 pi over 360 times 30. And that is ABC. And then for PQR, right, is R also. That's the radius of the circle. And now I want it to be 45 degrees. So I can just go back here, and from my 1 degree, I can say to make it 45, I multiply by 45. So from here, I'll just say instead of multiplying by 30, I multiply by 45. So I can get 2 pi over 360 times 45. So 45 degrees converts to that. 2 pi over 360 times 45. There we go. And now what we want is we take this, the length of ABC, and we divide it by this, the length of PQR. And let's see what we get. And so we take R, 2 pi, we can take the whole chunk, over R, 2 pi over 360 times 45. And what do we notice? We notice that the R's actually cancel out, which is wonderful. And for the rest, you can actually key into a calculator and you can get an answer. Or if you prefer, you can simplify it. So I'm just going to simplify it. So whatever you're comfortable with. If you're not comfortable simplifying because of all the fractions, you can just key the whole chunk into a calculator. But the first step is I'm just multiplying the 30 into the numerator to get 60 pi, and 45 into the numerator here to get 90 pi. And then after that, I realized that this is 60 pi over 360 divided by 90 pi, and that gives me I flip the fraction when I change divide to multiply. The pi's cancel out, and then I just continue to simplify. 360's cancel out, and then divide by 10. This gives me 6 over 9, which can be simplified to 2 over 3. There you go. So let's do part B, and now it says if arc ABC is actually 12 cm long, so now they're telling me that this is actually 12 cm long, that means this is actually equal to 12. They want me to find PQR. So what I'll do, I'll say that, okay, so you actually over here equal to 12. So what can I do? I'm just going to do my working over here for part B. So I'm going to say that R multiplied by 2 pi over 360, that equals to 12. And what this allows me to do, it allows me to solve for R, right? So I just write down the relationship they gave me first here, and then I say, okay, what can I do? Oh, I can solve for R. So let me solve for R. R multiplied by 60 pi once again equals to 12. And then I can say that R is equal to 12 times 360 divided by 60 pi. And that gives me 72 over pi. And I'm choosing not to substitute any value for pi yet, because I still need the value R. So I'm just choosing to leave it as pi, so that I don't have any rounding off error. And then now I found R, what can I do? I can say that, oh, I can plug that value of R into here to find PQR. So I can say, if I put it here, I can say for PQR now, which is what the question is asking, arc length PQR is therefore R, which is 72 over pi, multiplied by 2 pi over 360 times 45. There you go. All right. So just to recap, we gave them, they gave us that this value ABC is equal to 12. We just write it down. We say, oh, we can solve for R, so we solve for R, and we find that R is equal to 72 over pi. And then the question says, can you please find arc length PQR? So we say, okay, we already have an expression of PQR. We just don't have that R value, but now we solved for the R value. So we plug it in over here, and there we go. The rest is just algebra, so let's simplify that. This is actually 72 over pi. You multiply it in times 2 pi over 360 times 45. It's all multiplication, that's why I can multiply this way. So pi is cancelled out, and then you just simplify, and what you get is 18 cm, because it was cm. Yep, 12 cm, so 18 cm. There we go.